Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history, beyond our dreams and our sights. Life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
Okay, hey, and we are here, guys. Welcome, everybody. Welcome to the Benson view. Look at that. This is the moon, and I also want to welcome Daryl to our show. Hi, Daryl.
Hello, Mark. How are you?
I'm
Hello,
good.
everybody.
We're good. Yeah, it's gonna be pretty cool. I know we're competing with a state of the state speech, but that's okay. I figured tonight would be fun to just check out the telescope in Benson. It's a little fuzzy because there's high altitude clouds right now out there, but that's okay. We're only planning on looking at the moon tonight anyway. Now Daryl and I were talking earlier about the craters that we're seeing here, some of them, and we're doing our actual exposure here is 146 milliseconds. Okay, just so you know, that's like just over a tenth of a second as we expose here, and it looks pretty interesting. I'm going to drop the music a little bit. There we go. And by the way, the music's all new too tonight. That's another thing I did the other day. We're looking at this little tiny crater right here, which is, you see a little black dot there, and then a ray right here. And not sure which one that is. Now, the moon's orientation is important to understand here. This, by the way, we have both observatories open, just so you know. Right now, this is Benson, okay, and this is Wickenburg, okay, the Sonoran, and this is the fit size of the moon in this one. You can see how much smaller it is compared to this one, right? And in this one, let me fit the width so you can see the size. That's the size of this field, right? So here is the size of our field. Okay.
Okay, that makes more sense.
Yeah. And
Your field is 33 minutes across by 22 minutes tall, if I remember right.
that is correct.
So that should neatly fit the diameter of the moon, which is about 30 minutes, or an arc, you know what I mean, 30 arc minutes.
30 arc minutes, half a degree.
Half a degree, thank you.
Yeah, that's that, and it will. And one of the things that we're gonna do is we'll be looking at the moon a variety of ways tonight, and I'm gonna move the telescope down this way a little bit. All right, and you'll see that on the terminator we have this beautiful central peak right there, just starting to come out. That gorgeous central peak. That is that crater. I forget. Is that Archimedes? I think this might be. See, I'm looking at it kind of at a 90-degree shift from what I've been used to, because we have yet to get our field rotator, so we can rotate the images to be the same in both telescopes, and we're going to be able to do that. But that's pretty cool. Daryl will figure out what crater this is while I'm doing all the housekeeping here, I hope.
I will.
Yeah, hopefully.
There's too much detail on the moon. I can't keep much of it straight. You know, you mentioned a minute ago that little ray we thought we saw, whether that might be the crater Messier or not.
I'm not sure the rays are going the right way, but maybe they are. I think they are.
Well, yeah, if you rotate that thing for a natural angle,
Yeah.
The rays would be pointing to the left, more or less.
Yeah, so that would work. Okay. I think we're seeing that. Okay.
Can you zoom in on it?
I could. We could try, even though it's going to be a little bit fuzzy due to this cloud cover.
Yes, that's Messier.
Yeah, there it is. And there's a second crater right there next to it. See that? We have two right next to each other.
Messier is a famous twin crater, folks. It's a rare case where it looks like a large meteor or asteroid came in and struck the first crater at a glancing angle, and then continued on and struck the second crater, which produced the big ray you see there, angling down to the lower right.
Yeah, it's a very, very low incidence of attack, angle of attack, to create a very specific line of dust heading out in one direction. The other thing, by the way, that's really interesting about that theory is that if this is the first crater that was struck and this was the second, there's an issue with that, because we would expect to see some debris in this first crater, or some type of, pushover into this crater, but we don't really. So what it might be is that when it came in, the lunar gravity split it in two. That's another theory, and it sent it out. It sent it down into this one and into this one, where it was vaporized upon impact, but it was a low glancing blow, which means less energy of impact. Because if you notice, all these craters on the moon that you see are round. These are kind of elliptical. You can't really tell, but they're sort of elliptical in shape, like an ellipse, and that's a low energy impact. Because what happens with high energy impacts on the moon is, when we look at any other crater here, it's beautiful. you'll notice that they're round, round, round. And that's not because the moon is getting hit straight down on top. That's not at all what it means. Think of it like skipping a stone on the water. When you throw a stone on the water, it skips across the water. As it skips across the water, every place it hits, even though it's moving that in like 25 miles an hour down into the toward the along the surface of the water, even though it does so, every place it hits, it makes concentric rings where it strikes. That's because there's a component of the energy being transmitted straight down, and that's what we're seeing here. The component of the energy that was transmitted straight down onto the moon, and these could be coming in at all different angles, all right? But that's with a high energy impact. With low energy impacts, all right? So in other words, something that might have been in orbit around the moon for a while and just started to decay slowly and slower. What will happen is this object actually ended up slowing down just enough so that it could strike the moon at that glancing blow, and because so, it did what the last skipped stone puddle rings do on the surface of a pond. They drag out a little bit before the rock sinks, and so we get this elliptical crater. So think of the moon like skipping stones on water. When it has a lot of energy flying across the water, it goes ding, 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 ding across the top of the water, and it leaves perfectly round concentric rings. But when it stops, it slides a little and then sinks. And that slide is kind of what we're seeing here. Luda, you can see the turbulent air here in our view. So that's the basic idea. Now, the other thing that makes things more complex is the fact that, and Daryl's talked about this, I've talked about this, some craters are simple round bowls or depressions. Those are called simple craters. Some look like this, where they're actually a crater that has a depression, and then it has this mountain in the middle called a central peak. Now the central peak is kind of like the bloop from a splash. When you drop something in water, it goes, right when it drops into water, and it goes bloop, and up comes a little central peak in the water. But because water doesn't freeze that way, we get that bloop goes back down and the water just levels out. Well, with rock, when you strike it with a lot of energy, it becomes liquefied. That's called liquefaction. In an earthquake, when there's shaking and shaking, houses can literally sink like they're in water because they're sinking into the earth that they're built on, and they can be completely undamaged, but down the whole floor. That happened in the Marina District in California during a Loma Prieta earthquake. Okay, and so houses, the whole first floor was just subsumed into the ground, but it was totally undamaged. So that the shock wave will liquefy momentarily, will liquefy the soil because of the vibrations, okay, and it'll make the dirt, it'll come splashing back into the center and make a peak, and then the vibration is dissipated in the rock strata, and you're left with a central peak. And so that's kind of how it's a good analogy for how these actually form, these central peaks on the moon in these craters. And some craters are even more complex than that still, and I don't know if there's any now that will show it well. I mean, this one may show it if we zoom in a little bit. Let me drop the exposure just a little to kind of darken this image a little bit. Well, you can't really tell, but this has terraced walls. It has a central peak, and then the walls have like these stepped terraces of debris. Copernicus crater is a famous example. This one's a good example right here. So you have these terraced craters that have little rings on the ground, the ripples, like those ripples moving out from the splash. And soil acts the same way when it's going through that liquefaction process while it's in the middle of an impact. All right, so that's kind of a simple way to think about how the moon craters form. Right? Daryl, if you want to add to that, feel free.
Busy.
Okay.
I'm trying to figure out the quick map. Do you recall offhand what I need to do to get names to come up?
Oh, yes, you got to go over to overlays on the left side. You may have to hit an icon to bring up the overlays, and the one you want is nomenclature. Talk about often.
I don't see nomenclature.
Okay, so under layers, nomenclature. Well, you see that moment where that just got really clear? That's where the clouds are disappearing and going in between the clouds. No?
Well, yes, I see them now. Problem is, I see all of them.
Yeah, you gotta zoom in to. You gotta zoom in. You're right.
Come on.
And it can be a little bit slow depending on your computer.
Well, you asked me to name that
Yeah, this crater.
one central crater.
Is that Archimedes?
I want to say that's Theophilus.
Theophilus. You might be right. When the sun is just coming up on this.
Thing of overwhelming detail here. Yes, I believe that's Theophilus.
Okay, Theophilus crater. You can see the central peak. So from the top of the central peak in Theophilus, you'd just be able to see the sun peeking above the horizon on the moon. You know, the astronauts said something really interesting, guys, and that was that when they're on the moon, they see the bright sun up in the lunar sky, quote unquote, yet it was a black sky with the sun brightly seen in the sky. It was a really, truly alien environment because on our planet, obviously, we have blue sky and we don't see stars. Well, they didn't see stars either because their eyes had to dark adapt first. They'd have to turn away from the sun and away from the moon and try to look up in the sky as their eyes dark adapted, and they'd have to remove their gold visors that protected them from the ultraviolet, and those would just slide up. So even the astronauts with their own eyes didn't see a lot of stars. But they were able to use instruments in the Apollo capsule on the way to do star fixing and figure out where they were.
Did you see the great color picture of sunrise from Blue Ghost today?
I did not.
Excellent photograph. It's the sun is a big, huge, blaring, really dazzlingly bright thing up in a black sky.
All right.
And it's all in full color, so you can see all the, like the gold on the satellite or the lander.
I'll have to check that out. By the way, for those that may or may not know, most of you probably do, because you follow everything we do on this channel. This is Mare Crisium on the moon, and in Mare Crisium, the first commercial moon lander landed the other day, called the Firefly. It was Firefly Aerospace that put it on there, and the lander is here in Mare Crisium. So the sun is now up in Mare Crisium, which means that the lander will have a great time imaging the moon. And I don't know how long it's supposed to last. I really haven't even checked that out yet.
They're going to go for 14 days, and then they're going to see how long the battery holds up.
Okay.
And the lander's proper name is Blue Ghost.
Blue Ghost, that's right. Okay.
Made by Firefly. Anyway, yeah, that Crisium right there, that is, well, that's where the Blue Ghost landed.
Yep, right here.
If you've ever seen me talk about the rabbit on the moon, Merocrisium is also the cottontail on the rabbit on the moon.
Is this the eye of the rabbit?
No, that's his back leg. That's his back legs there,
Okay, so
and that's like the back half of the rabbit you're looking at.
okay,
And the cottontail's at his butt. His body is going into shadow down below, and tranquility, and the other one there at the upper right, that's his back legs.
right here.
When we get close to a full moon, you'll be able to see the entire rabbit. His head is to the bottom, toward the left in a conventional view, and his ears are flapping over his back, sort of at the top of the moon when there's a full moon. And if you're looking at it from Earth,
Very cool.
this is all camera angle. Speaking of camera angle, rotators and stuff, did you see that video I sent you from the CEO of ZWO? He's promising a lot of new things coming out.
Yeah, I saw. I'm really excited, and I'm trying to hold back my interest because that translates to a lot of potential things we don't necessarily need right away. We need the rotator because we want to match our views. Like, and I just want to show folks. Okay, see this the telescope here? Telescope there is pointing to the upper left. This is the north wall of the observatory on the Benson Plateau where we are. Okay, this, if you notice right there now, here's the telescope in the Sonoran Desert. And notice it's pointing in the exact same direction. That's because this is also the north wall. I set up the cameras to be in the same relative positions so that we'd be able to see the telescopes pointing in the same relative place when they're going anywhere. This is our moon as seen there. And if we zoom in here, and I'm sorry, Daryl, I know I'm only sharing that one screen with you. If we zoom in here, you'll notice we can't really see the craters in here. We've got Pierce and Swift and a couple other craters in here that we can't see. And that's because even though it's focused, it's actually a wide field telescope, so we're using it. This is what it's used for looking at the entire moon like this, right? But when we go back to the Benson Plateau and we look there, okay, well now here we are meant to be able to zoom in and do more detailed viewing. One of the things we can also do with this is we can actually stack planets in here, and this is a planetary stacking program. Now I've only been playing with it a little bit, but this stacks the moon and you'll see it's getting sharper and sharper and sharper, and then where it gets to the point where I want, we've already stacked 15 images here. Okay, now you'll notice it's not quite perfect. Well, that's because we're not actually doing any critical guiding on the moon right now. If we were, this wouldn't look that way. So we're just trying to put it together really, really fast. All right. But
Marianne is here.
Marianne's with us. Hey, Marianne.
One of my favorites I pointed out to you earlier is the lobster claw there on the right, on the left.
Oh yeah. So let's go back to that. So that is right here.
Yeah. See, the crater's got a broken wall.
Yeah, we'll zoom in.
Makes it look kind of like a lobster claw.
Or a heart.
And it has a proper name, but that's because I can't keep all the names straight. I call it the lobster claw.
Okay.
The moon did an interesting thing a few years ago. There was, or might still be, an image up over at Space Weather of Venus and the moon were at a similar phase a few days ago, and a guy took a picture of both and put them next to each other at the same, to make them the same size too.
Mm-hmm.
Show what they look like.
Very cool.
If they were in the same phase, both the moon and Venus had to have a similar angle to the sun, though the moon and Venus itself weren't that close together this time.
Okay.
I've seen that happen a few times in my life, which is really striking in the eyepiece. And the moon is getting bigger night by night, of course, because it's rising every night, higher and higher.
Yeah.
And the Venus is continuing to grow bigger, but get skinnier and skinnier night by night. It's a very thin crescent right now.
Okay.
Anyway, carry on.
No, that's fine. I think that's pretty cool. I am doing my own little look-see here, trying to figure out where we are. I'm trying to figure out what is that. I'm trying to figure out what C that is. I gotta go back out. I know we're looking at it back, kind of rotated. It messes up our eyes. Okay, now I think I can figure it out. Okay, down from Mare Crisium over to here. Nectaris. That's Mare Nectaris, I think. Yeah, that might be Mare Nectaris.
The one your pointer's on?
And this might be.
That's Sea of Fertility, isn't it?
Is it?
I think the one closest to the top between Crisium and the one you're talking about, that's Tranquility.
Yep.
That's where Apollo 11 landed. Darn this map. They're just drowning me in details.
Yeah, this is Tranquillitatis right here.
The one to the right is Mare Fecunditatis, which means fertility.
Is that the one I'm looking at? I thought this was Fecunditatis.
I'm looking right at it on the quick map.
Okay.
Sea of Fertility. Nectaris is
It's this one here, I thought.
it's the one to the, well, your angle is going to be different. Let me look again. Okay, that is Sea of Fertility.
This is.
Yes, the one to the left of it is Tranquility.
Right.
And Mare Nectaris is the one below Tranquility, I believe.
Down here?
Yes.
Maybe you're right.
I'm looking right at it on the LRO quick map, Mark.
Tranquillitatis. I should just turn my phone upside down here. There's Crisium. Alright. Yeah. I don't know. Okay, well, it doesn't matter so much right now, but I guess Daryl's probably right, of course, but I can't see him. Okay, fine. You're right. Okay.
I thought I was wrong once, but I was mistaken.
You're mistaken. That's right. I was trying to actually find the actual formal name of this guy here at the edge.
Yeah, so was I. Let me see. Doodah. Everything's turned around.
I know it. All right, so Crisium's there. Left is right, right is left. Up is down, down is up. Okay. So that's there. What is this? What is that? Is that it? Nope. Well, it's okay. If you find it out, if you figure it out, let me know.
I'm looking.
Okay.
It's just the overwhelming amount of
Yeah.
names and stuff on this.
Yeah, he's looking at
I'm not even sure if that one I said was Theophilus, if it really is or not.
Yeah, that's...
It is a well-defined crater. If it is Theophilus, that's the one that's Cyrillus right next to it. And then a little dumbbell bar, and then Katharina down below them.
Yeah.
Let me look again.
Yeah, Cyrillus would be tied into it, but it might be still in shadow right here. And then down below it, and we have this guy, which is Modeler. Right there.
Okay, so no, that is not Theophilus.
Yeah, it is.
Yeah. Is it?
Because this is Fractorius right here. Fracastorius, I'm sorry. This is Fracastorius. The wall has been broken down and lava overfilled the interior of this previous crater. And this is actually Mare Nectaris. Right here.
Wait, which?
This is Mare Nectaris. Because that's actually Fracastorius right here.
I beg to differ.
Okay.
Let's see a fertility. Mare Nectaris is below it, to the lower left.
I don't often disagree, but I'm disagreeing. This is that crater I was just telling you about, Fracastorius. This one is the next one down, which is Beaumont. Okay, and you come around, all right, and then you have this very well. Let me get back to this.
That crater,
This very well defined crater's Modeler.
Langrenus.
And this is Theophilus. You were right about that.
No, it's not.
Okay.
Theophilus is overlapping Cyrillus.
Yeah.
And then Cyrillus is connected to Katharina down below.
Yeah, and if you notice, here is the bright wall between Theophilus and Cyrillus.
No.
Okay.
Well, Cyrillus is about the same size as Theophilus.
Yeah.
Okay, and that's a much smaller crater.
Well, I'm not talking about this. I'm talking about
Yeah.
this.
Okay,
It's
well,
in the dark.
All right.
Yeah, let me zoom in a little more. I'll show you. Okay. Now we get to here. Let me actually do this. Okay, so here we are. Now, one of the things too that is that I'm looking at here is if we look at Fracastorius, which I believe is this one, all right, then right in this case below it, or in our case above it, is another crater, which I can't quite identify yet on this lunar map here, but it's there. I see it. Yeah, this I will bet dollars to donuts that we're looking at Mare Nectaris here.
Nope. That's Sea of Fertility, and the crater there is Langrenus, I believe.
Well,
Then Mare Nectaris is under where, if you look at it where, okay, you basically got all right, I give up. Doodle.
hold on a second. Let's see here. Yeah, there you go.
Detail here is just Mercurium,
Now this is
Mare Tranquillitatis,
Nectaris.
Sea of Serenity is above Tranquility, and Sea of Fertility is below Tranquility, and then Mare Nectaris is to the lower left of Sea of Fertility.
I have a one-to-one correspondence between everything I'm looking at here. This is Fracastorius. This guy
It's not.
This guy right here, okay, that you're telling me it's not, is actually a Beaumont. This right here is I don't have a name here for this. And then this is Theophilus, and then this little crater right here, okay, is Madler. A with an umlaut, so Madler, Madler. So,
All right, you're right there. I see Theophilus and Madler.
okay.
Mare Nectaris is to the southeast of Theophilus.
So you're saying that it's down here?
I'm trying to look at three different things at once. Say it again.
So you're saying that it's down here somewhere?
That's Nectaris right there.
Hmm. Okay, Nectaris is in sunlight right now. All right. So,
That one? That's fertility.
no, this is Nectaris. Okay. I believe very strongly that this is Nectaris, and I'm giving you my reasons for it. I think it's kind of fun to go through this. Okay. I mean, I'm getting one-to-one correspondence in every crater I'm looking at. Okay. Fracastorius. Okay, then this one here next, if you go down the line, this one is Beaumont. And then you have Theophilus here. Cyrillus is here. Okay, and you can't see it because it's not clear yet. And the wall of Theophilus is very famously bright at this point, and it connects to Cyrillus right here. All right, and that's what I think we're looking at right there. This small one here is Madler, and then we continue around, and we have some highlands here. Let's go see what those are. These highlands, okay, yeah, okay. This crater is Sandbeck. And we have Montes Pyreneus at this side of Nectaris over here. Let me just put the pointer where it belongs. Yeah. So to the left of that, this is Montes Pyreneus right here. There's a little crater in here, which we can not. I'm pointing in the wrong place.
Izabela's here.
Oh, Isabella's been here. Hi, Isabella. I forgot to say hi.
Been too busy looking at the map.
I know. See this little crater right here next to Fracastorius, that one right there in the backside? Okay. That one is called, let's see if I can get the name. Oh, it's not named on my map. It's below the detail level of the map. Oh, but, how about this guy? There should be a crater right here named Rossi. Right here. And it looks like it's on the left side of Rossi is here. Just about right in here somewhere is Rossi. Yeah, I'm pretty sure that that's Nectaris. I got one-to-one correlation all the way around.
Put down the bong, dude.
How could you not see this? Fecunditatis, okay.
Okay, Messier crater. Can you find that again?
Yeah, it's up here. Right here. It's tough to see.
It's just to the lower left of your pointer.
Yeah, no, it's here, but I'm getting clouds going over the moon, so it's hard to see.
All right, that is Sea of Fertility.
This is, yes. And this is Nectaris. So we're good.
Nectaris is
this. Oh, you know what? We're looking at the moon oddly shaped right now because we don't have it rotated to rotate it to a view that we're kind of used to seeing. However, we do.
well, yeah, you're.
What's that? Let's do this. We could have actually. I don't know if this will help, but I zoomed in on. I zoomed in on the other one. Okay, let's go there. Whoops, that's too bright. Too bright. Let's zoom down. Or cut the gain a little. Okay. I put the gain up a little on this. I'm going to drop it down.
Can you hear me?
Yeah, I hear you fine. Yeah.
All right, I accidentally kicked my cable and unplugged something.
Well, you're back. I'm glad. Glad you're back.
I'm getting cross-eyed trying to maintain orientation between.
I don't blame you. Yeah, that's okay. Well, in any case, one of the things that's very interesting is that we have a new way to view the moon that is actually really cool. And I really like the fact that we can look at different parts of the moon at much closer range and see some very interesting details. All right. Yep. Okay. Now, one of the things to look for when we're looking at the moon is look for any little dots passing in front of the moon. Because those would be satellites seen between us and the moon and in our, in orbit around the Earth. Now, the International Space Station, when it goes by the moon, it goes really fast. It goes zoop. It's literally there and it's gone. It's so fast. But satellites at higher altitude show up as little black dots slowly crossing in front of the moon.
I once saw the ISS with the shuttle, which had just disconnected from the ISS. I once watched both of them pass right over the face of the moon.
Oh, that's cool.
And it was gone in, like a snap of the fingers.
Yeah. It goes 30 arc seconds, or 30 arc minutes in no time. Now, one thing, too, about this telescope is we can see the lunar mountains on the rim. See that? You can actually see this elevated area right here. And that's neat. We see all kinds of those elevated areas. And that's really helpful when stars are transited by the moon, when the moon passes in front of the star. Because sometimes you'll see the star appear for a moment and then vanish again because it's going between lunar mountains on the limb. Really interesting to see that.
Yeah, and the high points and low points along the edge of the moon's limb like that is what produces Bailey's beads during a solar eclipse.
Exactly. If you haven't seen Bailey's beads, that's where you get these bright spots around the edge of the moon. And that's the sunlight coming through the valleys between those peaks on the very edge.
They said something really interesting in one of the Firefly releases for Blue Ghost, that they are looking forward to when the sun sets at the Blue Ghost There's a phenomenon called, they call it levitation. The lunar dust supposedly levitates at sunset. I'd never heard of such thing.
I haven't either.
And they're going to be watching for that when the sun sets in about 2 weeks.
So I wonder, is it just dust that's always in orbit around the moon and being backlit by the sun?
I don't know. They called it levitation.
Interesting.
Like it some way rises off the surface when the sun sets.
Yeah. I'm gonna check our weather because we had high altitude clouds out there earlier tonight, and I'm just curious if we still do. I imagine it's only going to get worse, but we'll see. Okay, open the window. Oh yeah, we still have some high altitude clouds, but you know what? It's really not. Wickenburg is going to get, and the Sonoran telescope is going to get knocked out first, and Benson will follow a little bit later. But we do have some high altitude clouds, as you can see here. Well, look at that, huh? That's a beautiful moon. If we drop the exposure a little bit, I know it looks dim, but if we then stack, let's see what that does. So we just stacked 15 shots, 20 shots, 21 shots. And looks a little rough. That's okay. I did that with Jupiter the other night, and we got a beautiful image of Jupiter. You might be able to do that again. So that's cool. Jupiter's right nearby anyway. I've actually always been so like, the moon again, the full moon's coming, darn it all, it's going to ruin our viewing. But now with this telescope, it's not as big of a trauma for me anymore, because hey, we can now view the moon, you know, and I'm really excited about that. I had the building open, by the way, for 45 minutes before we streamed, just so I could get the telescope cooled down. Our temperature on the sensor of the camera, which is right there on the back end of the telescope, the temperature is minus 19.8 Celsius. The temperature in the building right now is, let me just pull this up. The temperature in the building is, where is the temperature? 13.4 Celsius. Yeah. And you can see here where it says tracking. Notice it has the moon on it. That means we're tracking the moon. We can track stars, we can track the moon, and we can track the sun.
Yep. They used to build those into telescope drives. Hand controllers would have
Oh yeah.
a switch with the names of the different settings, so you could track the moon or the sun or stars.
Yep. That's cool. Yeah, so this is nice. Okay. Now, we can do is go back over to Sonoran telescope. Let's go see. Let's go. Let's take ourselves over to Jupiter right now. So we're gonna go from the moon. I know you can't see this, Daryl. We're gonna go from the moon over to Jupiter, which is not too far away. So let's do that now.
Why can't I see it?
Because I only shared the other screen. I didn't share.
Oh.
Alright, so Jupiter should come in. There it goes. There it goes. And I have to just go back to fitting our width. There's Jupiter. Look how small it is. Okay? So we can zoom in on Jupiter here, and you'll see that there's like very little detail that we can see on Jupiter. Now we are looking through some light clouds in the Sonoran as well. But let's see what it can do here. Let's see if it can actually stack. Well, it's stacking now as we speak. You can see the stack count going up. Yeah, it says stacking FPS low. Cloud? Yes, cloud. See? So, as an example, stacking through clouds in the Sonoran doesn't really help us much. Okay? So, if we go back over to here, to Benson, now we're in Benson again. Let's go over and look to see if we can zoom in on Jupiter here as well. Alright, so let's go see if we can find Jupiter here too. Zoom, and away we go. There it is. And right away you can see cloud bands on Jupiter, and we haven't even done anything yet. So this is the benefit of what we call focal length. Having focal length is a good thing. Alright, let's just center it up. As I said, once we have the rotator, oops, went the wrong way. Once we have the rotator, we'll be able to get this all oriented properly. Alright, so we got that, and we got that. Okay, so now we zoom in on this guy, and we can see that we have what looks like a basic cloud band in there. We see some others. Alright, let's see if we can stack this now and see what that does. Let's see what I want to do here. Again, we're through some light clouds, so it's kind of hard.
Would be interesting if you had room for the filters on your filter wheel. Good old color filters of various tints are really good for bringing out detail on planets sometimes.
Yeah, yeah.
Mars will show dark details, and
Yeah.
different colors will pull up like different cloud details and such on Jupiter.
Yeah. See, we're getting some artifacts because of the clouds, and that's part of the issue. But I will say that Jupiter does end up looking quite nice. And I took a beautiful shot on a clear night there in the Benson Plateau with this telescope, with this product, and I could see probably 12 cloud bands and the Great Red Spot. I could see detail within each of the bands and the belts, so it was actually really nice. But because we're looking through high clouds, we're kind of limited tonight. But we'll get to that. We'll be able to get to that at some point again. Yeah, you see how the red and blue separation occurs? That's definitely cloud problems. You can start to see a little detail, little colors coming through. You know.
The south equatorial belt is the darker of the two, isn't it? The one we see now?
Well, south is up here, because the Great Red Spot's on the southern part, correct?
Right.
So that's this way.
Okay.
So the way the camera, because the way the telescope's rotated,
Yeah.
the camera's gone upside down, basically, effectively.
That's really throwing me.
Me too.
Fantasy is so soon, 5 days. Mercury is rising, I know, and Venus is setting, dropping night by night, and they should be in conjunction soon. I'd have to look it up.
Well, I think I'm remiss in actually saying hello to some of the people that are out here now. Tiffany was first. Hi, Tiff. Carl Becker is here. You can see the people who don't listen, they don't want to hear President Trump. They'd rather listen to you and I. Daisy and Zoe are here. Nice to see you. Steve Smet, Carl, Mr. Django, Carl Becker, and we have Sally Forth is with us. Hey, Sally Forth, how are you? And the Goblin's with us. Nice to see you, man. Sam S is here. Michael Hedrick, of course. He's always here. So good to see you, brother. And let's see. Hein Sherry is here. Hi, Hein. How are you? Hein Sherry. And Stuffy's with us. And Star Voyager, Genghis, Karen Belmont. What's up? And let's see. Blue Whale Studio. Blue Whale Studio, Blender Animation / Dominoes, etc. I'm a Cinema 4D guy, but I've used Blender. I have it on the machine. Nice to see you, Blue Whale. Let's see, what else? Am I missing any questions that might be cool? Would be neat, Star Voyager says, would be neat to see that asteroid hit the moon. Last I heard, odds were low. Yeah, it's down like 0.2% impact on the planet Earth. Slightly higher for the moon. If you go back to our streams, Blue, and you go back to the January 2019 lunar eclipse stream, we did catch a meteor striking the moon, and you can see the flash of it hitting the moon right where the moon is red. So at the height of the eclipse, we caught the impact. And there's only 5 groups on the whole planet that actually caught it, and we were one of them. So that was pretty cool. We just happened to be looking at the same time, you know. Fantasy's with us. How you doing, Fantasy? Good to see you. C&D boy, hey man, what's going on? Donald Kunzer, and the cast of characters, and Marianne Robb. Marianne is very, very cool. She's just finished a meeting with UFO Bureau. I know Mindy and the group over there.
What Daisy and Zoe said, we remember that night. God, that was 2019, wasn't it?
Yes, it was. January 20th, 2019, I believe. Yep. Kathy Brennisek, hi there.
Ooh.
Yeah. And let's see, who else did I miss? Going through the list. Dagger's with us. Dagger Spells, how you doing? Doc from Wyoming. Doc says anybody else's audio cutting in and out. Marianne says audio is good. Audio okay on our end. Daisy and Zoe. Okay, Sally Forth restarted. YouTube, it was fine now. Okay.
Fantasy, I looked up the conjunction, and 5 or 6 days, Venus and Mercury will be in conjunction.
That's very cool.
Dropping like a rock.
Yep.
Interesting when we see that. Mercury is actually pretty easy to see right now. If you got good skies and you go out after sunset, give it a half hour or so after sunset for the sky to start to darken. You'll see Venus brilliant up in the west, and right below it, and a little to the west right now, a little to the left, lower left of Venus, but getting closer every night, you'll see what looks like a middle and bright star, and that is Mercury.
Yep.
And in 5 or 6 days, they're going to be right next to each other. Venus is dropping toward the sun on this side of the sun, while Mercury is coming around the side of the sun.
Awesome.
So Mercury is rising and Venus is lowering.
Very cool.
Mercury will be in conjunction with the Sun on March 22nd or 23rd, after which it will pop up in the morning sky again. And how we've seen Venus in the evening sky for months, well, it's going to wind up in the morning sky for months now.
And that means we're not going to see it because I won't be up at 4 and 5 in the morning.
Yeah.
Hmm.
Mercury, though, if you get the chance, go out and look. Mercury is not easy to see usually. This is a favorable apparition that Mercury is coming up high enough that we can get a decent view of it.
Mm-hmm.
And if you watch it through a telescope, you can see that just like Venus, Mercury will also go through phases like a little tiny moon. Even smaller than Mercury, even smaller than Venus, though. But you will see, as Mercury comes around to this side of the sun, it will turn into a crescent, just like Venus is right now.
Yep. See, we're starting to get more cloud bands on Jupiter right here. Other than our silly artifact here. Yeah.
I have too many windows open.
I'm familiar with that issue. Alright, let's see where this is going to take us. Okay, you see that? Look at that. Let's zoom in a little.
Yep.
Yeah. And I can't really tell, but I don't see the great red spot. It must be on the other side of the planet right now.
I'm trying to look that up right now. I thought I'd saved this. It must be on the other computer.
Mr. Django. Oh, you know, there's people out there. By the way, I didn't say hi to you, Izabela, and I'm sorry. I didn't finish going through the list. Thank you for putting up our image folder. And Alice Pooper's with us. How you doing? Okay, I got to go through and finish this. Okay, and I think that's... We got Sally Forth says, I live in Pittsburgh and usually miss all the cool stuff because it's usually cloudy. Sally, make sure you subscribe and hit the like because we're always doing cool stuff. I mean, look at this. Look at Jupiter. Right? Except for that weird red artifact, which is probably because of the moon right nearby, causing a little issue. That's actually a live artifact. It's not a stack artifact because it's creating this live, and it's just because the telescope is pointing in such a way the moonlight is still coming in and kind of going off there. But look at how nice that looks. And now we can play with getting some of this sharpening done here. Get some of this done. Okay, a little much. Go back on that. Take another fine approach here. Look at that. You can now see a separation between the belts and bands here. That's nice. So that's pretty good. Not bad. Not bad for Jupiter.
The band on the upper right looks like an artifact.
This?
Well, the one above that.
This here?
Yes.
Well, this isn't away. But as it comes down in, you'll see that it adds detail that's not necessarily there. And I want to actually remove a little of blue. Okay, because when I do that, you'll notice that it's correct for a moment, and then we get the artifact coming back. Yeah, okay.
Will your scale catch the planet and the moons at the same time?
Oh, because they're so Yes, I can see the moons. If we pull out of this, let's come out of this. I'm just gonna save this anyway.
I don't want to mess up your
Yeah, I understand.
Europa. Excuse me, Io, I believe, will be to the lower right. This orientation really screws me
I
up.
know. Just follow the horizontalness. Okay, let me add. Let's just do a quarter second shot here. All right. And then-
Io should be on the lower right. In a conventional view, it would be to the left. Then Europa, Ganymede, and Callisto
okay, we have to do some focus too.
on the right, which would be the upper left from your present orientation.
Okay, I'm going to actually do that too. This might actually make it better. Let's drop this back down. Yeah, there's 1, 2, 3, 4. You see them there.
Yeah.
So we have Io in the lower right, and the rest are up top.
Yeah, Europa, Ganymede, and Callisto.
Yep.
From Callisto is farther north
Okay.
than the Europa or Callisto
All right. Let's see what
or Ganymede.
this does. Okay. A little bright. Look at that. Wow. That red dot is again, that's a live artifact from the moon. It's funny. All right, let's zoom in on this. That's cool. Nice. That's really cool. You can see detail within the cloud bands, the modeling and stuff within the band. That's actually neat.
Yeah.
Let's see if this makes it a little better. Oh, look at that. We caught the moons.
Yeah.
So like you suggested, this is a ghost of Jupiter. See, that's Jupiter with Io, that ghost image. But we have the 3 moons here and Io down here. Well, 2 moons anyway.
Yeah, Europa closest, and then Ganymede and Callisto is
Outside.
not quite in view.
Yeah. Well, if I zoom out, it might be. Unless that's it there. I don't think it's that. No, it's not that high. That's cool. Look at the detail that we can see. That's pretty cool.
Yeah.
Yeah. Not bad. When the moon's not out, we don't get this. Oh, that's an artifact, that vertical thing. Let's drop that out. Drop the brightness a little, and then come back out. See, I know it's barely visible there, but then if we actually stack it, okay, then we start to get more details. We get more data in our stack. It's pretty cool.
Great red spot will be around in about 3 hours.
Okay, I don't know that we will.
Yeah.
But that's cool. Let me just increase our exposure a little bit. And come out of here and just... Now you see, initially what you're looking at is you're looking at this right here and you say, wow, that's fuzzy. That's not very bright. But really, that's a function of the seeing, the nature of how clear it is between us and there through our atmosphere. But when we look at this, okay, we can see that there's a lot of detail hidden in here. We can see modeling at the poles. We know that's really there. Let me increase that a little bit more. And do it again.
Well, not a lot of detail out of that.
Yeah. Let me drop that level 2 sharpening down. Look at that.
We've actually, that thing I thought was an artifact,
That's the belt there.
the one above that, there's actually a white spot in it.
Oh yeah, right here. That's
Yeah.
right. You're talking about. You're talking about
The uppermost, the
this
band most to the upper right.
this
Yes.
little white spot.
Yeah.
Yeah.
Well, it looked crooked before. It's actually got kind of a zigzag in that cloud,
Mm-hmm.
and then the white spot is below the zigzag.
Yeah.
You kind of see it right there. Interesting.
Indeed.
Have you tried Mars yet?
I did, and it was really small even in this. I need a Barlow lens probably, but I could see some surface detail with the initial tests anyway. And this is really nice. Let me see if I can get some more detail out here. Okay, we'll do this piece of detail. Let's see where that goes. That's a little bit too much. How about if you do this? Okay, we're getting a fuzz, so we're getting a cloud.
Yeah, I see that.
A little bit of a cloud going through.
Oddly enough, the best views I ever had of both Jupiter and Mars
Mm-hmm.
was with a camera attached to the telescope, looking through the viewfinder.
Oh, yeah, okay.
And for some reason, that viewfinder, like on the old SLR 35 millimeter,
Yep.
it just turned incredibly crisp for a moment. And I saw detail pop out on both of them like I have never seen since.
Wow. I was using a 20-inch Alvin Clark refractor. So I was working on the parallax program at the university. And I saw Jupiter and I said, I'll go look at Jupiter. And the way the telescope was set up, it had a big flat glass, clear glass plate at the back side. And for an eyepiece, you held up this giant 3-inch diameter lens, and you put it up and looked at it with both eyes. Okay, it was the coolest thing. And you put it up against the plate, and it had a cushion on it. You just slide it around, and it was just beautiful. Well, I looked at Jupiter, and I nearly dropped it. I counted over 20 cloud bands on Jupiter without even batting an eyelash. It was just like, wow. It stood out like just amazingly so. So it was really, really pretty. I was very, very impressed with that. Very impressed. So, okay, well, I know that it works, and we know that it can get some really cool detail when it's not doing ghosting.
So why is the red image there?
That's ghosting. It's a see. The problem is the moon is shining into the telescope as well because it's pretty close. So we're getting and Jupiter's very bright too. So we're getting this secondary image of Jupiter in there as well. Just I'm not sure the geometric orientation is such that we're getting it. Sometimes it happens. Most times it doesn't. We don't get it unless we're actually doing the stack, as you can see here.
Oh.
Yeah. All right, so what we're going to do now is let's go back, fit the width here, and let's now go back to our other view. This is the zoomed in portion. So if we try to stack this guy, all right, you'll notice that it really doesn't get much better. It's just what it is,
Is this still the 11-inch or the 10-inch?
No, see here. Oh, you can't see it. Sorry, my apology. I'm in the Sonoran now. We're getting some cloud bands on Jupiter, but it doesn't look that good because, again, this is a wide field system. You know, a tiny Jupiter. Heinz says, yeah, exactly. Okay, and then back to this guy. All right, you know, we're fitting the width here, so it's actually pretty wide, or pretty much bigger. But I don't know if we could actually catch Mars here, but we can try it and see.
It's well placed.
It is, but I'm worried about the telescope placement. Yeah, so we're good there. Will we see it though? There it is. There's Mars. Okay.
It's red.
I know, huh? Go figure. But even in this scope, it is kind of red, you know. So let's kind of pull the telescope down a little bit. That's too much. And then pull it over a little bit. Wrong way, Feldman. Need that rotator, I can tell you that. Yeah.
Mars is small at the best of times, folks.
Yeah.
Mars was in opposition, a couple of months ago now, I guess.
Yeah.
And that's when it was closest, biggest, and brightest. This time around, even at its closest at opposition, it was a so-called aphelic opposition, meaning it was far from the sun, so it was far from us. It only got to about 14.5 arc seconds across.
Yeah.
While when we were looking at Jupiter, might be 50 arc seconds across right now. So this wasn't the best appearance, but with modern cameras, guys were taking some pretty amazing pictures, even so. They were using more specialized cameras. A lot of guys use video cameras and take a whole lot of images in short order. Then they stack them all and reject all the bad ones, and they were managing to catch quite a bit of detail on the surface of Mars.
Right, through lucky seeing.
Even at such a distance.
Mm-hmm.
And since then, well, Mars has grown dimmer, and it's getting smaller and smaller because we've moved ahead of it in our respective orbits around the sun when we were at opposition. Mars is going to keep chasing us. He's like the guy in the rearview mirror you just passed going down the highway.
Yeah.
And he's trying to keep up with you in the rearview mirror. He's going to be up there for months yet. Mars was all the way over in Cancer, and then as we approached opposition, Mars backtracked. It reversed its motion in the sky until it's in Gemini, and it's still in Gemini now. It's up sort of to the right and between Castor and Pollux, if I remember correctly.
It is.
But Mars will eventually start moving west-east again in direct motion. And then for months to come, it'll be racing to keep up with us, slowly falling farther and farther behind.
You'll notice.
But still, because it's relatively close, it's going to keep racing across the zodiac in the coming months.
And you also notice that Mars is not perfectly round in the view. That's because Mars can appear like a gibbous moon to us sometimes.
Yeah.
And that's what we're seeing here. Okay, this is the side that is, the rest of Mars is over here. We're not seeing it all, but you can actually see some dark spots on the surface here. And I'm going to reduce my exposure a little bit, and then try to do this. Now you'll notice the sky is not still. We're looking through clouds, but if we get some lucky seeing, maybe we'll be able to, do something here with Mars. All right. Let's. Yeah, we're actually. Yeah, the angular diameter of Mars is so small that we need a good still night for this.
Yeah.
So Mars won't come out good tonight. It comes. It's actually. It actually appears better by looking at it here, and you can actually see that might be what Syrtis Major up there, maybe. I'm not sure.
Yeah. Maybe.
Hey, Carl, thanks for coming. I'm glad you could stop by and hang with us for some planets and moons. All right. Okay. All right, so that's cool. Now, one thing that I also wanted to do while we're here is take us down here. Why not? I don't want to look at the GOES geostationary satellite. Let's go down here to Beckland's star, also known as Theta 1 Orionis. Okay. Which is one of the trapezium stars, I believe.
All right.
So we're going to now head down there with the telescope. And we're going to come out of here.
I never heard that name before.
I know. Welcome to Stellarium. All right, and now what we'll do is go to our classic low light mode shot here. There it is down there. And so what we'll do is bring the telescope view upward into the view. There's the trapezium coming in right there. It's not bad considering what's going on out there, and you know the alignment is just really nice. Thanks to David at Star Arizona. Well, there's a trapezium, those 4 stars. Okay, and if we run over now to this other, the Sonoran telescope, let's go to the same view here. All right, and let's go look at it from here as well. All right, so that was, oops, okay, let's do this. There we go. I wish Betelgeuse would go supernova so we can have something cool to look at like tonight.
I've been watching videos recently. I don't remember the guy's name. He's on YouTube. He's an English fella.
Yeah.
He talked about Betelgeuse in a recent video and said a lot of really interesting things. Probably stuff we've both all heard before, but the guy just really has a way of presenting what he's talking about. I'll have to see if I can find that. He did one on Betelgeuse. I've seen one on Sirius. He did one on Barnard Star also.
No.
Really interesting guy. See if I can find him.
Let me get out of this mode now. And let's see if we... Okay, we're idle right there. Let's zoom in. I want to show you what I can of the trapezium as seen here. And as you can see, we're going to focus again. Let's see, we go that way. Okay, other way.
The guy's name is Paul Fellows, Fellows.
Okay.
Just for future reference, folks. He does really neat presentations on the various stars and stuff. Paul Fellows, English guy.
Cool, all right. Very nice. I'm just doing a little focus here. So here's the trapezium as seen in this, the Wickenburg telescope. Now, the actual size, if we were to fit it, is this big. See how big that is? That's tiny. And if we go over to the Benson side and we go to the Benson Plateau, this is how big it is. That's the full size right here. You can see the heart of the Orion Nebula here. Okay. And so the comparison is actually, very easy to make. Okay. If I do that, you can see the whole size of the nebula. This is why this is a wide field scope and why this is not a wide field scope. This is a more high focal length scope. All right, and so that's what we see. The greenish blue color here is the ionized oxygen in the Orion Nebula, and it glows a predominantly teal color. So why don't we start? Let's try actually to bring up our guiding program. I just calibrated last night, so I don't think I have to do another calibration. Once I connect, we should have our calibration data. Alright, so now we will go do this. And now I'm gonna try to grab a star or two. Alright, got that. Let's guide on those and see if that'll work. Guiding worked very well yesterday when I did testing. It was actually even through light clouds. So let's now do a 20-second shot with the 11-inch telescope here. Alright, we're still guiding. That's our star right there. It's down here. And let's see how that works. And okay, so that worked. Alright, so it's still guiding, so now we'll go in our live stack. And we can also bring this up as well. And there we go, and you can see now this this beautiful core of the Orion Nebula here. And we will color correct it. And then we'll do this to start showing off what it looks like in there. Color correct again. Okay, let's I'm just working on trying to do a few things here. Color looks a little bit off right now, but that is oh, that might have been me. I think that was me.
What was you?
The color being off was me. I think I adjusted it for the moon and not this, so let me do this again. Okay, yeah, that was me. Okay, so the Orion Nebula then has these beautiful blue wings here of ionized oxygen, and this is, let me back out a little bit, this is our full field. What's interesting is with a 20-second exposure we can still see the trapezium and the core is not blown out. Now the moon has a way of increasing our contrast of all our images, right? So we do have to play a little extra to get additional data out like this, okay? But right now, this is an extremely, it's more red, it's got a lot more color in it than it really ought to. It should be more down to like about here. Okay, so the moon does add an extra layer of complexity to our imagery. So now if I come here and I do the same 20-second shot in our other view, okay, so we'll do 20 seconds here. All right, and we just head off into that direction and do our live stack there. You will see a different image. It'll be, there's our Benson view right there. That's just beautiful. Okay. And then over here, we're going to have our Sonoran view come in. All right. And so what we're going to do is color correct first and then run this through our curves. And there you go. And now you see the entire nebula, right, in this way. So that is, we fit the width of our sensor across here. All right. So if we go back to Benson, this is the width. Let me actually fit the width and make it the same. So there's the width now, exactly the same. All right. So we get a lot more detail in here, and the guiding is just, we do have some wind gusts out there, and so that's what these double little star images are. I just removed them by unstacking that last image. I mean, we're still doing okay. The wind is just comes and goes out there. So isn't that beautiful? That's gorgeous. So I like that. So much fun. Okay, that'll be M42. But I named it that, but just for fun we can actually just bring in the naming and show you. Okay, so there is NGC 1976, Great Nebula in Orion. We can change the name. I like that. I won't save it because I won't save the detail here because it's overwriting itself. Neat. And then back in the Sonoran, SkyTour Sonora, we get this. Let's color correct this a little bit more. This isn't bad for having a near first quarter moon out, but could it be better? Well, sure, and it could be better if we didn't have the high clouds that we're dealing with. We still do have the high clouds.
Izabela asks if any globular clusters would be visible tonight. M13 or M3. M13, I know it's too early for it.
It is. Well, maybe not Benson, because we can look toward the east quite nicely, but the roof doesn't go all the way off yet, the building. So when we look at Benson here, you look at up there, you look in the building there, you see this is not the full image though. This is the full image. There's the roof of the building. It should literally be all the way to the right. So we're still a foot over where we should be, and we might clip the roof looking for M13 right now. Well, we could try. We could look and see where it is. Actually, we can do that right now. Just look and see while we're capturing these images here. Alright. Okay, good. We're still going there. Alright, calibration is going strong. That's nice. Alright. So now if we do this, and do I have M13 in here by any chance? Doesn't matter, I can just type it in.
You might get Messier 3.
Yeah, maybe.
It's in
Yeah.
Canada's Benetisi.
Yeah, that's right. And we don't.
I think it's too early for Hercules.
Oh, it is. Yes. I was just showing that that's true. Okay. So now, there's the moon, Jupiter. We slide over back to where we are here. That's where we're looking now. Let's Cadence Meditici's out there. I mean, we should be able to see it. Coma Berenices is coming up.
You got the Stars of Spring coming up now in the east.
Yeah. Okay, so there is Messier 3. And its actual altitude is about 16 degrees, more than enough for us in this observatory. So we could try and find that. Let's first of all, let's save this. Save it exactly as seen. Okay. And then we'll hop out of here and go back to our low light mode, which is kind of cool. Alright, that's our low light mode. And let's now see if we can head over there. I'm going to stop the guiding here. We don't need this now. Let's find out if it can see M3. Try it out. There it goes. It's heading up, heading out to the west. It's going to go to the east. I don't know if it's going to see it, but we're going to find out. 16 degrees should be enough. Let's see where that's looking. Might be looking at the roof at this point.
Yeah, it kind of looks like you're looking right at the corner of it.
Yeah. I think we are. Yep. I think we are.
Yeah.
Okay. Well, not yet. Not yet, Izabela. Not yet. But actually, let's bring the gain up a lot so maybe we can see.
Globulars are more of a spring to summer thing.
Yeah. See, I'm at 250 right now. See, we've been photographing without gain up at all. It was down to 0. But that's okay. I don't think it's going to know where we are right here. It doesn't look like there's enough stars for it to figure it out. Well, yeah, okay. So, we can't see enough of the sky. Alright, so let's see, what else do we have in that region? Any other globulars this way? Do we have any others? We have Coma Berenices
There's M53 right there. You just went right by it.
Yeah, Black Eye Galaxy.
No, M53 Globular.
Yeah, where did it go?
It was off to the lower right,
Oh,
right there. There's
yeah,
another one below it.
that's at 18 or 17 degrees. So that's not. Oh, we can see where that is. Let's see, find out where that's gonna take us. It's not too far away, but it's a little higher in the sky. We can try it. See what we get. Yeah, don't. Let's see if we can plate solve for this location. No, not enough stars. Yeah, we're looking at the roof a little bit too much here, so we're not able to get over the roof, which is kind of why it looks sort of brownish here. So we're looking at it like with the equivalent of maybe like a 4-inch telescope right now. But let's go. Let's see about going up into Leo. So this is a little higher. We have these galaxies. What's the sliced onion galaxy? Have you ever seen that one?
Don't remember.
Okay, well, let's see what it looks like. If we can get to it. Okay, now we're above the roof.
No. Leo's getting up there now.
Yeah.
Should be able to see it.
Yeah. Let's bring the gain way up just to see if it's hiding here.
Mark, would you excuse me a moment, please?
Yeah, go ahead.
Right back.
All right. So, found this. And you see 3323 is just out of view. That's what we want. That's what we want. 3323. Oh, that's 3344. Okay. Is this 3323? 3327. Let's bring in the viewfinder here. It's not where we are. We're supposedly here. That's where we're supposedly located. All right, let's see. We're not that far off. Yeah. All right. Let's go back to this alone and just try this. And can we get to you? 41 Leo. Okay. And now, can I sync with this? Plate solve and sync. Okay, we'll try that.
Find it yet?
I plate solved and synced, and then it went to the star that I asked it to, which is right here.
Algebra?
And so now,
That's like the back of the lion's neck.
there. See, here is Leo the lion. That's his back of his neck. Yeah. And so, where was I going? Which object?
Sliced onion?
Oh yeah, this guy, right?
Or the splintered onion or something.
Yeah, there's something weird. Okay, we'll go there.
I think the Splinter Galaxy was Django talking about that.
Oh yeah. Okay, there it is. All right, let's see what the Sliced Onion Galaxy has to offer, shall we? First, let's come in here and let's do a bit of a stellar field. And let's see if we can grab a star in here. Not yet. Okay. Okay, I'm just gonna do this. I'm gonna actually pull it down a little bit, darken the field a little, and see if I can select some stars to guide on. Okay. Well, that should have worked. I had one there. Okay, we can try that. Doesn't quite see it, but it does, but it doesn't. Alright, well, let's see what it does. Okay, we're gonna do 25 seconds and see how this works. And we'll come out of our low light mode, go into our stack, our live stack mode, and we're going to see the Sliced Onion Galaxy. Hopefully it comes in pretty good. I can actually just pop this up here and keep watching it. Oh, there it is. Look at that. Looks nice. I'm gonna move this down. This is our mid-level, and then I'm gonna darken the background. So that's pretty cool. Look at that.
I have a question.
Yeah.
Your light curve now seems different than it used to.
Yes.
There below the image. I mean, it looks more compressed over toward the left side, where it used to seem to be stretched out more toward the right.
Yeah. If we go to the other one, our curve is like right in the middle here, right? And the reason for that, first let me just take care of the housekeeping here. Let me do this. And we'll do, okay, that's what we want. Set the target name. And we're done. Okay. Let me save it. The reason has to do with If I'm getting my guess right on here, I think it has to do with both the focal length and the camera itself. Because that's like we're looking at like the histogram where the data falls, and on this other telescope, it's actually falling further to the left. I can't really fully explain that, but I will do my best to figure that out because that's been bugging me too. Oh, look at that.
The line you just dragged,
Yeah.
there's 2 dashed vertical yellow lines.
Yes, this is the black level.
And the other one, I can't quite read it, mid-level.
Mid-level, yeah. And over
Can you
here
drag that line to the right?
If I move it to the right, it'll knock out noise. You see, watch. So it goes away.
Okay.
Noise goes away. And,
Very good. Put it back.
Yeah, and if we go this way, what's happening is we're doing what's called a push. We're pushing the processing when the black level and the white level or mid-level are coming closer together to each other, we're pushing the data up and compressing it all in between 2 ranges, and that makes it look brighter and grainier. So if we come all the way over here, you see more detail, and what will happen is the image will fall into being able to accept that amount of detail as we acquire more images. Right now we only have 7 acquired here, see? Those 7 that we have acquired there, now 8, those are good enough for a view like down here, okay? And this curve can continuously slide more and more and more to the left the more images we acquire. Right now, that's actually pretty nice. We can see some pretty cool stuff there. And I guess that's why they call it the sliced onion. It's a beautiful face-on spiral galaxy. You can see the spiral arms very nicely. I've never looked at this before. Probably because...
Izabela says we did once, about 2 years ago.
But that was with this telescope, right, Izabela? The Sonoran?
Well, it would have been, like 2 years ago.
So it was going to be a very wide-angle view, so it probably was unimpressive to us. Now we're looking at it, and it's actually impressive. Most impressive. But you are not a Jedi yet. Very cool.
Apology accepted, Admiral.
Yeah, that's right. Remember that? Apology accepted, Admiral. The rebels are alerted to our presence. Admiral Ozzel came out of light speed too close to the system. Ah, Lord Vader, we have just... Guy was a jerk. Okay. There we go. Alright, so... guiding is working great. Blues Traveler says a new slice. Yes. Admiral Ozzel is as clumsy as he was stupid. Thanks, RJP. Yeah. Izabela, thank you for getting up. I know it's early for you. As it was for Steven Smet, Mr. Django. But, very, very nice. You guys set your alarms for this, and it makes me feel very, very good that you feel it's worth doing.
Can you zoom on that at all?
Oh yeah. If we pull the white level or mid level down, I can then zoom in on this a little bit more and capture some of the detail.
Okay.
Interesting, does it looks like 2
stars?
Yes,
that's what I was wondering.
I wonder if that's actually part of the OB association and an outer spiral arm.
Kind of what I thought.
Yeah, it looks markedly blue. It'd be interesting to know. Actually,
interesting galaxy.
Yeah, let's find out. Let's push this and see if there's detail out there. It follows a logical curve for like this spiral arm.
Right.
So it might be interesting to see whether that is. This might be a barred spiral. Look at that. I'm going to go look and see if this is actually a barred spiral. Okay. May I see what looks like a bar here? Well, let's go see what this says here. Yes, SB. Well, no, it says SBC. It would actually be a capital B if it was a barred spiral. So it's an SB/C. So it's a SA is a very tightly wound. SB is a less tightly wound, like the Andromeda Galaxy. SC is loosely wound, let me unstack that. SC is loosely wound, like M33, the Triangular Galaxy.
I bet this would be really something on a clear night.
Yeah, I know. We're looking at it through clouds.
Yeah, you can faintly see tons of spiral arm detail in there. Some of it's barely visible.
Yeah.
There's some passing underneath it, and like along that curve, that blue thing you were looking at.
Yeah, right there.
Going clean over the top, over toward. If that's at about 2 o'clock, then go all the way over to about 10 o'clock or 9 o'clock.
You can see it come right around.
Yeah.
At least it looks like it is. All right, well, here's what we're going to do. I am going to move this over a little bit so that I can bring up my guider. That's cool. All right, so this is our screens for Benson. This will be our screen for Sonoran. A little bit different, but this telescope is eventually going to be taken off the fork mount that it's on now, and it's going to go on another exact mount like this. We have 2 of these mounts, and we're going to put that telescope in Wickenburg on a mount like this, and it's going to go in this same observatory right here, across, like, closer to us. So we'll have this camera plus another camera looking at the other telescope. So yeah.
Are you happy with the what is it, EQ6R?
Yeah, it's actually
So far?
very nice. It's not the EQ8, but the EQ6 is still good. EQ8 has more capacity and it's a little updated. But what I did was, this was having troubles where it was running away in the right ascension. It would start going and nothing I could do could stop it. I had to shut off the power. So what I did was, remotely from here, 2,600 miles away, I had to get into the guts of this mount and I had to change the software in the motors that drive the mount. And I figured out a way to do that, and I was able to get this to respond beautifully. So I bought new equipment too that we're going to install. It's an update to our USB hub, extra power, and so forth. And I'm going to install a system to mitigate any problems where the cables, see these cables here? These cables actually hang down a little bit into in the way. And sometimes they can get caught on the bolts sticking out of the pier down below near the floor. So I'm going to install a cone around the base of the pier. I call it it's just like a cone shield or a pier shield. Mr. Django says, Mark, did you lower the declination aggression once to 75% for a test, maybe smoother? Yeah, I did. If you notice, the guiding at this end is okay. I changed the algorithm, which I will show you. Let's see, is it under? Where is it? It's under here somewhere. Not under the guiding assistant, is it? No. I went through this and I got some numbers from it and I used those. You'll notice the declination aggression here is 100. I noticed I had to bring it up to 100 in order for it to be able to correct properly. I did have it down to 50 and then 75. And the aggression is the amount that it corrects, because it can overcorrect and go up and down and circle around the points it has to get to and never reach them. So this was a good way to test it. So I did testing previous weeks and found that right now the aggression on the right ascension, if you call it that, is 61. Okay, and the aggression on the declination axis, you know, how intense it tries to correct, is set to 100. Most of the error is in the declination side.
Django says he used 75 with his EQ6R Pro.
Yeah, it depends on the telescope you're using too, Steve. You know, the magnification, focal ratio, and all that.
The thing I wondered, reading on those mounts a little bit, just their belt drive, I believe. Not that there's anything wrong with that.
Definitely got a mark here. You're right.
Yeah, yes. Once upon a time, would have been a worm and worm gear.
Yeah, I'm thinking, I think the EQ8 may have worm gears, and maybe the E6 has belts. I'm not sure. I don't know. I have to figure that out.
Well, the EQ6 has been around for quite a while.
Oh, yeah.
Used to be you could buy an EQ6 mount. Back when they first came out, it was like $600. And I bet you pay a little bit more than that for yours.
Oh, gosh. Yeah, these mounts were $2,000 each.
Yeah. And the EQ8 is it is a much larger mount. It's more heavy duty.
Yeah, and
kind of a step up from the 6, of course.
Steven, confirms that the 6 has belts. I think the EQ8 has worm gear. I don't have one to look at, but I thought I saw that it has a worm. I could be wrong about that. But, okay, so I'm going to... Okay, we got that error. We're going to change the target name to that. I haven't saved it yet, so we're good. I'll save it with annotations. And
I think that definitely deserves another visit.
On a clear night when you don't have high clouds.
Yeah.
That's not bad for high clouds, though.
Sort of like the group you noticed up at the upper right.
Yep.
I think there's another one down at the lower left at about 7 o'clock.
And here.
Yes.
Yeah, I think that this is a continuation of this spiral arm. You can see it.
Yes, and a dimmer one over at about 5 o'clock.
And yes.
That might also be on that same curve.
Right here. You can see this almost continues all the way around.
Yeah. Well, there's that particular
This one goes around there.
fuzzy patch down at 5 o'clock, though.
Yeah, we're getting some good detail on the spiral arm here. Look at that. Yeah. And this modeling, that goes away once we process it. And like right here, you can start to see this is pretty good for 35 images, like you see right here. But if we want to really make this noise go away, we want to really make it look bright, well, then what we can do, let me just do this actually. Now I see as time goes on, the histogram does this where it can move into the middle more. Okay.
Michael H. has a question.
Yeah. What's he ask?
Oh my word, so many spiral arms. How many can they have? Anybody? Question mark. I know you said this was an SBC Galaxy. Does that mean loosely wound?
It means across half between medium wound and loose wound. Yeah. And I think that means that it looks like an SB in the middle here, but it's more like an SC on the outer fringes, see?
Oh.
And we're catching a lot of this extra detail. This is about the same distance as this. This is a little further.
Well, I can follow that spiral arm.
From here. All the way around.
Actually, it's going all the way around back over to 3 o'clock.
Yeah, I see that right here. It goes.
No, I'm go farther out.
Oh, here?
Farther out.
This here?
Yes.
I see something here. I see something here too. I'm wondering what that is. We'll have to see. We'll have to look up the.
Oh, I can see the spiral on that one running all the way, going clockwise.
Right here.
To the one we noted there at 7 o'clock, and
yeah, this goes like this.
On up over toward 9 o'clock.
It's almost like a ring. It's almost like this is all part of the same ring. I mean, again, galaxies do have differential rotation, meaning that the inner stars do go around the center a little bit faster than the outer stars. But there's not enough of a difference to be explained by ordinary, Newtonian physics, okay, and kinematics. The problem is that the galaxies seem to spin more like a rigid disk, okay, than like a loosely wound connection of stars that would wind up the spiral arms in a short period of time, relatively speaking. So I think that's the main impetus for trying to find something to explain what could be pulling those particles in the stars and other dark dust and stuff along with the central stars at least part of the way to make this so that the galaxies don't wind up over time. And that explanation is founded in the concept of dark matter. So dark matter may exist, dark energy may not. Michael Hendricks says, how is this possible with a small land-based telescope? This is with high clouds? Awesome. Yes, it's high clouds. We're looking at it through high clouds. That explains a lot of this noise in here too, by the way. We're seeing noise of the clouds in here as well. Theoretically, okay, if we were to, with 44 images, this would be almost black space here. Okay, and if we drop this down, okay, we kind of artificially remove the noise a little bit, and you can see the galaxy a little bit better. Now, I can also enhance it by turning off sharpening, and that will get rid of some of the noise as well. All right. So we get rid of some of the noise a little bit, but I prefer having the sharpening on so we can look at the detail in the spiral arms a little better.
Some of those arms are quite distorted. Are there any other galaxies in the neighborhood that might have caused an interaction to do that?
That's when I looked here. Okay, I didn't see anything other than this guy. Right now, this galaxy is at a distance of about 19 million light years. Okay, about 20 million light years. This galaxy, right, is 335 million light years. So, no, that's not going to be...
Not that one, anyway.
No.
Well, I just wondered, because, I mean, the some of those arms in the galaxy look really distorted.
Well, galaxies interact with themselves too. That's the thing, and that can happen as well.
I mean, there's one that starts just at about 12 o'clock, closest to the center.
You mean here?
Above, next one out.
That one?
right there.
Okay, yeah.
That looks like it's got quite a crook in it.
Yeah. Well, this one looks like it has an angular shift in it too. Nice. And you got to keep in mind too, the moon is also adding additional sky brightness that is robbing us of some of the darkness that we might see. No matter what we do, no matter what filters we use, I mean, we still end up losing a little bit to the moon. Okay, so if we come out here, you'll see the sky brightness increase a little bit. Okay. Well, this is nice. I'm going to save this at 50. Not bad.
If I was to do it on a clear night, maybe run a critical focus first.
Yeah, I didn't do a critical focus within the last hour, but I did do one beforehand, before we started on this telescope. This telescope is less sensitive to focus changes, which is kind of interesting. It doesn't have the same mirror flop problem that this telescope has. Which, by the way, we're still looking at this. We're going to save. We did 100 frames. So that's going to make a beautiful shot, even though the moon is out. All right, so we'll save it exactly as seen. Now let's come out of this. Let's go back into our low light mode here and explore something else.
I'm going to have to call it a night pretty soon.
Okay.
I know we talked about streaming for an hour, and we've been going over 2 now.
You know what? That's true. I'm always doing that. Okay, you know what we're going to try before then? Let's see here. Let's come back. We're going to go back out to our size. Look at that. That's pretty. Okay. 54. I'll save that. Save it exactly as seen. And now what we'll do is come back out, and we should probably do one more. Do you have any suggestions? Does the chat have any suggestions? What you'd like to see? We'll do one more. No suggestions. Beehive Fantasy says the Beehive. Hey Wayne Pinkham, how you doing, man? RJP, how you doing? And he says, like something wound that thing up tight. Maybe not a collision, but perhaps a strong and relatively recent gravity tidal effect. Like I said, galaxies do interact with each other, and can knock themselves off kilter, especially if new stars form from the mass that's there, and form these mass concentrations, which can change the nature of the spiral arms, and they can warp their own galactic disks and stuff. So that's also very possible. Let's go here. Okay, it is not reacting to me.
I noticed.
Oh, yes it is. Let's go look at something. Alright, well. And now it's reacting. Strange. Okay. I can't wait to see the helix in this, I can tell you that.
Well,
That's going to be gorgeous in here. We're going to catch those fine filamentary radial streaks inside there. I guarantee it. That's going to be really something, don't you think?
sure.
Okay, let's why don't don't we? You know, I was thinking.
You're an Ursa Major now.
I know. I was thinking
M81, M82.
maybe we should try the Cigar Galaxy. I don't know. I mean, it's kind of in the same region. Telescope will turn to the left and face out the building there. Want to try that?
Sure.
Okay, that'll be our last object. All right, so... All right, we're going to bring us back here to fitting the width. This telescope has a relatively larger field, too, which is interesting.
What?
This telescope, this particular camera, has a more rectangular sensor than this other one. When we look at the other sensor, it's actually it's less rectangular and a little more squared off, whereas this one in Benson is actually more rectangular. Okay, all right, telescope's pointing out there, and I wonder if we know where we are here.
The ratio of width to height is about the same for both, 3:2 roughly. 3 units across, 2 units high.
Yeah.
This one though is about a half a degree by 20 some odd minutes, and the other one is a degree and a half by a degree.
Mm-hmm. All right, let's do this. I'm going to come back here. I'm going to tell it to plate solve and sync. And that will take us to that galaxy. All right. All right, so this is Messier 82, which is what's called an irregular galaxy. It's a galaxy that could be has been interacting with M81 nearby.
Yeah.
And so it looks really interesting. I'm going to go and see what we have for guide stars here.
This camera seems to have better red sensitivity also.
Yeah, it didn't the entire time I was using it the last time. We had it on the other telescope because it wasn't actually red sensitive at all, and I discovered that I was using the wrong profile for the camera, which was just crazy, you know.
Well, I remember looking at M33 in Triangulum at what's the big area in it, NGC 604.
Yeah.
That it never showed red well.
That's right.
When it's actually, you see other images of it, and it's M33 is just full of red stuff.
It is. That's right. We may have to grab a different guide star here in a bit, but we're going to try this.
Izabela, somebody, I don't remember if it was Anton Petrov or who, mentioned recently that white dwarfs were a good place to find planets.
Wow.
Exoplanets, they said. The only downside would be that I would think the white dwarf is putting off radiation. It would probably sterilize those planets.
Absolutely. Okay. We lost the guiding. I'm going to pause this. I set it up so that this application sees what what it's what this is guiding on, a separate thing. Okay, so we take care of this. Interestingly, I noticed that I can tell to just find stars and not actually have it guide, and I will get good exposures. And I read somewhere that it's because the calibration that the guiding program was trying to do was not done, or was off. And I still would get good imagery, and I couldn't explain why. And so we're going to find out now if I'm still going to get good imagery here. I can always unstack this if it's not. Look at that. Perfect. Look at the detail in here, guys. Now, there's more stuff coming out here and here. It's starting to show now. And there's a lot of stuff. If we overprocess briefly, you can see there's a lot more stuff coming out of the top and the bottom here. And that'll all make itself evident. So that is the Cigar Galaxy M82. We'll set that as the target.
The starburst galaxy, is it?
Yeah, they call it the Cigar Galaxy in this, but yes. Starburst Galaxy. This red is massive H2 regions, that is ionized hydrogen regions. And those massive ionized hydrogen regions are areas where an incredible amount of star formation is going on all at once. You all right there, Daryl?
Yes, excuse me.
Yeah, sure. So star formation regions are just absolutely incredible. So we can zoom in on this now, and for the first time in SkyTour history, we can actually start to map out some of this dust in here we've never been able to see with this kind of detail. So it's really kind of cool.
I see a dark blob up toward the top.
This?
Up toward the, well, to the left.
This here? That's,
There, stop your pointer for a second. Now go straight up. Right there.
right here?
Just below that.
Oh, right here.
Yes, dark. That's real, I assume.
Yeah, it's a filamentary piece, apparently. Look at the delicate nature of this sweeping stuff here. This is crazy. Really nice.
And
The red is
also-
starting to show nice here.
above the nucleus,
Yeah.
there's that white area, bright white, and then there's, I see at least 4 areas right there, dark areas.
Yeah, okay. Yeah, let's go crazy and zoom in way more than we should.
Where we find dark areas.
Yeah, you can actually see here some really interesting stuff. All right, so what's interesting is the guiding program right now isn't actually guiding. I mean, it is, but it's guiding on non-star objects, and it's guiding perfectly. So it means that the calibration probably could be redone. But since I know it's guiding, I will figure that out at another point. But I like that it does this anyway. This is cool. Look at that. Wow.
It's nice.
Yeah. And let's bring our mid-level over and see if we can start to pull out those red central ejections that are going on here and here. We can. They're starting to show up now. Let's color correct this too.
Lots of modeling and detail inside that galaxy.
Yeah. The focal length of this telescope really makes it really beautiful. Michael Hedrick has a sideways question. How often do we see from our perspective galaxies edge on, and how often straight on? Face on, I think you mean. Well, it depends, of course. There's several trillion galaxies, but we see a healthy number of both types, and it's just statistics. It has nothing to do with any actual planning of the universe, you know. We have the was it silver needle, silver coin galaxy. Those are galaxies that are edge on. We have the pinwheel galaxy, which is beautiful. We have the one we just looked at, the sliced onion. That's face on.
Whirlpool's face on.
Whirlpool's face on, actually. Yeah, that's right.
Typically, the face-on galaxies, you'll see them called grand spirals when they're really good.
Yeah. Grand design spiral, for instance. Isn't that the pinwheel? I don't remember. Ben Izabela, how you doing? Nice to see you, man. You got here just in time to see our last object. Well, okay, I lied. Second to the last object. I gotta do M81 after this. I got to. Can't not do it. The wind has calmed down out there tremendously, so if you need to go, Daryl, I can understand.
Just one more.
You bitten by the bug. This is beautiful. Okay, let's see if we overprocess. Let's see what else is there now. A lot of data out here. A lot of data out there. Okay.
Izabela, geez, I'm having a brain lock. The Great Attractor. Attractor.
Yes. It's sort of in the direction of Virgo.
It's, yeah, God, I looked that up a dozen times. It's sort of southeast of Virgo.
In fact, the Virgo supercluster is heading toward it.
Yes, everything's heading toward it.
Yeah.
Everything in our part of the universe is.
It is a localized. It's a localized for the universe. It's a local attraction point. Who knows? We might actually have. We might even have other great attractors beyond our ability to see, because the universe is suspected of being about 92 billion light years in diameter, and we only see out 13.8 billion light years. Not even quite that, actually, but the universe wasn't visible for a few 100,000 years, so about 13.6 or 7 billion light years. So at that point, the light has taken so long to get here, from 13.8 billion light years, the distance of cosmic microwave background, that the universe continued to expand during that time, and so it got a lot further. And then, as we noted, the universe is accelerating in its expansion as well, as discovered with the change of the Hubble constant, which wasn't constant, as it turned out. And so that particular find showed that the galaxy, or the universe actually, was expanding and getting bigger and bigger for 13.8 billion years, even faster than we ever thought. And when you put it all together, it comes out to a diameter of 92 or so billion light years in diameter.
Great Attractor is about 250 million light years away in the direction of the constellations Triangulum Australis, the Southern Triangle, and Norma, the Carpenter Square, down in the southern sky. The Great Attractor is the apparent central gravitational point of Laniakea supercluster.
Oh, yeah. Look at the detail. You're starting to see filaments here. This is 24 exposures. Let's go back to this and see if we can pull a little more detail out of this. And let's bring this just to the peak. Get our background as dark as possible. Go too far and it will start to cut it out.
The great attractor is hidden by the zone of avoidance. That is, it's sort of behind the Milky Way from our point of view.
Mm-hmm.
And looking at a diagram they have, it looks like it's below the horizon for us,
Mm-hmm.
to the south.
And that's not something we can see with the telescope.
Right.
By the way, I wanted to mention to you guys, for those of you that may be in Connecticut watching, on March 26th, I will be appearing at the Aquila's Nest Vineyard to do an astronomy program for the night, including a skywatch if clear. So you might want to come along and bring folks and come along, hang out for the evening, get a great presentation, and then if it's clear, we go out for a skywatch. I called Aquila's Nest to ask if about the genesis of the names of their wines. I don't drink wine, but the thing is, it's interesting because all of their wines, and they're in Newtown, Connecticut, all their wines actually have constellations, and they have the constellation history, which is very interesting. So they're heavily steeped in mythology. It's really kind of cool what Neviana, the owner of the vineyard, has done. Her and her partner. It's really cool. So I asked her if she wanted to have a astronomy presentation, and she said, "Oh, yeah." So that's cool. So it might be who knows? Maybe I'll become a vineyard astronomer. If people drink enough wine, I could point to anything in the sky and they'll say, "Wow, that was so cool." Just kidding, by the way, about that. So that's March 26th, 6:30 in the evening. It's on the Aquila's Nest. That's Aquila, Aquila, like the constellation. And it's on their website under experiences. You scroll down and you'll see for March 26th, you'll see my ugly mug, and it'll tell you about what I'm going to talk about. It's going to be a talk on extraterrestrial life in terms of the science we know. A lot of people like that stuff, it turns out. I didn't know that. It's pretty good. 32 images captured, all perfect guiding here. Look at the detail in here now, Daryl. Look at that. Jeez.
Yes.
And look at this stuff coming out up top. See that?
Yep.
Yeah, that's going to be a beautiful processing problem.
It was a long time ago. I seem to remember that back in the days of film, that red did not show up well.
You said that, and I think it's true, and I think it might be because the emulsions back then, I mean, it was certainly there, but I think the emulsions back then weren't actually red sensitive. I was using, and I talked to Izabela about this, I was using a film, 103AO Kodak film, professionally in the observatory, in the professional observatory, and that was a blue sensitive plate, if I recall.
Yeah.
And that 103AO, I took a picture of M82. I spent like 4.5 hours guiding on it. And I never even picked up a hint of these explosive tendrils coming out of the galaxy. They were there, but the 103AO did not pick it up. So it was a matter of the film emulsion and the capability at the time. That's what made the difference, right?
I would assume so.
Yeah, yeah.
When we see the other Boday's Galaxy, M81, I guess, or M82, whichever one this is not,
M81, yeah.
that these two are definitely interacting,
Oh, yes.
or have in the past, and they're relatively close to each other.
Yeah, they're close to each other in space and in the sky, you know, from a visual point of view from ours. All right, we're gonna go to 38 exposures here, and then we'll stop it and go to M81. M81, it also fills the field pretty well. It's beautiful. Okay, so we're gonna save this now, and then save it exactly as seen. And what I might do is process this and give it to you guys free so you can see the final processed image. Unless Izabela wants to do it too. She loves to do this too. Yeah, Izabela says, well, it was a blue plate, correct. And if it was a red one, maybe we'd pick it up. Now, when she says plate, you have to understand, telescope imagery used to be done on glass plates. Glass is very stable, and the emulsion very, very carefully applied, molecules thick only, and this glass plate was a very precise plate that you could measure details on very carefully. We used blue plates because that would actually put the smallest star image when we would take pictures of stars, because the study we were doing was parallax, distances to nearby stars. And so we had to actually use the blue sensitive, because that would give us the smallest star images, and therefore with the small star images we were able to get the best image, and then we'd have that small image on a glass plate, and we would send all the plates down to Yale because they had what was called a measuring engine, and they would actually measure very precise positions of the stars on the plates. And over the course of a year or 6 months, we would do those same stars again, and what you would see is that the stars shifted position against the background stars. All right, and the background star is much further away than the foreground stars, and it would tell us actually if it was far away or not. And that shift corresponded to an angle that we could calculate based on the size of our orbit, and that angle was called the parallax angle. And it's the same process where you have a left eye and a right eye, and if you put your hand out with your finger sticking up and you say, okay, I shut my eyes, and you blink your eyes left and right, you'll see your fingers shift against the background of the wall. Well, that finger shifting is the close star, and the background wall is the more distant stars. So you can figure there's a way to mathematically figure out the distance to those nearby fingers, those nearby stars. And that is parallax, and that is something that I was heavily steeped in doing studies for 4 years on that. So it was really quite interesting. Okay, I'm going to drop this down now.
And back when they used glass plates for imaging, believe me, the libraries were huge and very heavy.
Yeah, you bet you're right. You bet you.
And I mean that they stored the plates, and it was like a huge collection of heavy glass plates.
I have some of my own in the back room here.
Nowadays, they just put it on a computer.
That's right. That is exactly right. Okay. All right, let's see here. I'm going to do this. Okay. All right. Come here. Let's go here. Let's do that work. Okay, we're good there. Now we're going to be here, and we're going to head up to Measure 81. And this one should just pop in Oh, that was fast. There it is. Okay. All right. Let's go see if we're going to have some guiding stars to work on here. Let me increase the brightness. Okay, it looks like we're in the same relative position. That might work. Let's try that. Alright, we have at least 2 stars now. Let's see if that'll stick around. Okay. Okay, let's go, and that's perfectly placed. Let's do a 30-second exposure of this. Let's get out of our low light mode and jump into our live stack mode. And we'll bring this up to make sure that we're still good. I can shrink that a little bit. That's our star profile there. Oh, look at that. Nice. Yeah, that's with the moon. Let me color correct that.
Oh, I bet the moon is down
Yeah,
by
I was
now.
gonna just check to see. I bet it is. Yeah, it's there.
Oh, okay. Yep.
Alright, so we'll do this and this. There we go. Oh, what happened there? Unstack. Alright, so we're gonna stop doing that. Okay. I'm gonna try the same trick just to see. Unstack that.
I could almost imagine looking at this one, M81. You see the spiral arms are nice and regular, but they're kind of extended, and the one in particular on the above, M82 is above M81, right?
Yeah, I mean, if you look here, this arm is sort of distended out. This arm is distended out.
Yeah.
They're equally distended. It's kind of on a slight angle to us, a deprojected angle to us. Ever so slight, you know. Which is cool. Look at that galaxy though, huh? That's beautiful. And what we can do now is we can, let me make sure, okay, we're good there. Okay. Let's,
I mean, the distension of the arms, that would be the gravitational interaction we're seeing from M81's point of view, wouldn't it?
maybe, you know, I'm not sure about that because it could be that M81 might be much more massive, and so M81 is relatively untouched. But the thing is, again, remember these spiral arms, the stars circle the galaxy and they go in and out of the spiral arms. The spiral arms don't go around the galaxy like the stars do. Yeah, the galaxy rotation is exceedingly complex. The spiral arms stay there. think of spiral arms as traffic jams on a highway. Okay, you enter the traffic jam, you slow down for a little while, then you speed up and you leave. Meanwhile, there's still a traffic jam behind you. It's just different cars all the time. And that's what spiral arms are. They're traffic jams with different stars all the time. And again, it's millions and millions of years it takes for that to occur. But and you know this stuff, Daryl. I'm talking to everybody else. The stars are moving through the spiral arms, and the gas and dust and interaction within the spiral arms, does slow them down and cause interactions, shock waves. Stellar formation occurs within those regions, and then those stars move out. So we're looking at snapshots in time. Like, see all these stars here? Those stars are in what's called, this is probably an OB association in here. Hot young stars, perhaps. These spiral arms are markedly blue. Okay, this is young hot stars in here, billions of them. You can start to see the spiral arms in here. Look at that! Wow. Let me try something here. I'll try and do a color process here. Okay, interesting. Wow, that's something.
Dean, Mark could probably say it better than me, but there are density waves going around the galaxy, and those density waves are what are setting up the spiral arms.
Yeah, those density waves are what I'm talking about, Dean, as the traffic jams. Okay?
Oh.
If you look at a helicopter going over a highway and you see a traffic jam, it's not the same cars in that traffic jam the whole time. Some are coming in, they kind of get out through the traffic jam slowly, then they move out. But the traffic jam's still there. It's sort of moving along on the highway very slowly. And so that traffic jam in stellar terms is a spiral arm. That's the best way that I can explain it. I really think that density waves are a fascinating concept. They're also something that is actually pretty hard to understand, So that's very true,
Well, that would seem to say that the density waves are what's propagating the stars in the spiral arms. That would seem to me to say that as the density waves move around the spiral around the galaxy, that the spiral arms would move also, but they're not the same spiral arms, so to speak.
So to speak, that's correct, because the spiral arms are made up of the stars currently stuck there as they're going through.
Yep.
And when they do that, they interact with the matter that's also collected in those spiral arms, and that means that they will be slowed down and also be late to work, as Sam S. says. All these stars are late for work. I think that's hilarious. Well said, Sam S. Well said. And Sam S., by the way, thank you for supporting us. That's very, very kind of you. A little bit late, but thank you. Okay. Let's do... This is really pretty, I'm telling you. This is looking really beautiful, don't you think?
Yeah.
Yeah. We get so much more detail with this thing, I'm telling you. This new scope, we get a lot of detail, and it's very exciting. So I'm really happy about that.
I bet you retire that old Meade telescope.
I bet I don't. Well, look, if we can get some good support, my goal is to get a telescope larger than 14 inches and put it in one of the buildings, probably Benson. That's the idea. I mean, that'd be pretty cool, wouldn't it? Have a 17-inch telescope that we can play with. You know, just a little plane wave. You know?
Well,
Just a little one.
you'd need a pretty good sponsor to pay for a plane wave.
Yeah, I know. We would.
Well, there's always a C-14.
Yeah.
Some of the best views I ever had of anything was through the C-14.
Yeah.
But you're talking an awful lot of focal length there.
Yeah, was it F12 or something?
I want to say the 14 is an F11.
Okay. But we could put a focal reducer on it.
You probably would.
Stephen Smet, Mark and Daryl, thank you for all this beautiful long session. Oh, you're more than welcome, Stephen. Thank you for coming up. Leonardo Gonzalez, how you doing? Can we see Neptune? Yes. Yeah, we can, but not tonight, actually.
Neptune is pretty much lost in the sunset, huh?
Yeah, so we're not going to be able to see that, not at the moment. But
Neptune is pretty much behind the sun now. If not actually behind it yet, it is lost in the sunset.
yeah,
That's why this so-called planetary alignment going on. Neptune is actually the lowest one in the west right now. And Neptune, Saturn, then Mercury, then Venus. You'll be lucky if you see Mercury and Venus. Saturn and Neptune are both pretty much too low unless you have an absolutely dead flat horizon.
and then you don't want to look anyway because you got too much air mass you're looking through. Dean Bostador, by the way, hi, says, problem with the Meade scope, which I have, is where do I find parts now, even for even a mount replacement? Dean, that's the reason I didn't buy the Meade 16-inch when I had the opportunity. I could have bought one for $5,000. And you might say, are you out of your mind? Why didn't you do it? Well, because there are no parts available for them. Nobody makes parts. Everything would have to be engineered by a lab, you know, to replace something that's missing. It was in working condition, but it was being sold as is, which if you ever hear a telescope being sold as is, run the other way unless you have a chance to use it and make sure you're going to have spare parts for it. No as is.
Dean, you might check with High Point Scientific. They recently bought up the last stock of leftover Meades and parts, I believe.
I believe they did, yeah. High Point, North Carolina. Good people. Actually, the telescope in the Wickenburg Observatory is actually a High Point purchase. The LX600.
Yeah. They've been advertising what telescopes they have. They came into, though they're claiming discount prices, their prices are pure MSRP or higher, actually.
Yeah.
Just because they ain't making them anymore.
Yeah. By the way, this is the Sonoran telescope. You can see the high clouds. This is what we're imaging through in Benson over here. So, telescope sees the galaxies a little more reddened. All right. I can drop the red, but then it's going to artificially change the color of the background a little bit. All right, so that's more the appropriate color of the galaxy, but not the appropriate color of the night sky. So that's unfortunate, but that's just two things: lunar light involvement and clouds. So even looking through high clouds, that ain't bad. That's really a pretty image.
I don't recall. JSCO asks, have you imaged Andromeda with this telescope? You haven't, have you?
I have not.
Yeah. Andromeda's getting pretty low in the west now.
Yeah.
It's going to be going away pretty soon.
So we'll have to wait for that in Measure 33. Measure 33, that'll stick around a little longer.
Yeah. Well, not much though.
Yeah.
You'll probably have to wait till this summer before we get a good look at Andromeda or M33.
Yeah.
Later in the summer even.
Yeah.
Or later at night.
Yeah. Interesting thing about Measure 81 here. There is this fuzzy object here that I think we're seeing as a dwarf galaxy associated with M81. I haven't found it yet on a chart. I have to look. But I suspect it's a dwarf galaxy. Daryl and I have talked about this.
If you look closely, up at about 2 o'clock and then down at about 8:30, in the faint between the main spiral arms and outside, and there's quite an extended area down there at about 8:30, and then a smaller, pretty distinct one up at about 2 o'clock.
Talking about this and this.
8:30,
Well, that like over here.
right there, down there, down, right there.
Yep.
Is that area? It's kind of a wide streak of stars.
Yeah. And then it carries around there too.
There's a area outside the top spiral arm right about 12 o'clock. Right there.
Yep.
To the left. To the left. Right there, above, straight up.
Over
right
here.
there, that little faint fuzzy.
Yeah.
Right there.
That's pretty cool. All right, let's see if we can drop some noise out of here on us. We're gonna pull our mid-level down, which will allow us to get rid of some of the noise.
I haven't dropped a single image of this.
I know. I'm telling you, it's purring like a kid, and this is what we got. And it's still guiding on that one small star right there. So we do have one star in there, and we have another faint one over here. So just by letting it leave it to its own devices, it seems to be working okay.
Yeah.
This is 32 images, and
Right where your pointer was.
oh, sorry, yeah,
If you look right down below the center nucleus,
right here.
a very distinct dark strip right there.
Yeah. There's another one right here. Another one right here. Okay. That some of the distinctiveness of this and this and this could be the result of the way the light is hitting the dust or being backlit by the light of the galaxy behind it in our particular direction. Because you may not see it very dark over here, but if someone was watching from, say, over here, they might see a dark lane that's backlit by the galaxy looking this way from this side. So the visual appearance of the galaxy is not how it looks to everybody. This is just our particular one because of our angle of the view, which is interesting, actually. I'm going to just do this and see what it wants to do. Oh, that's nice.
Um, will you excuse me again a moment, please?
Yeah, go ahead.
I'll be right back.
That's really pretty. Yeah, this has hundreds of billions of stars in it. This galaxy does. Michael Hedrick says, to think how massive this is. Yeah, many, many billions of suns. You know, I mean, our galaxy has between 100 and 400 billion stars, but we're in the middle of that forest and we can't see the other side. Like, we're here, right, in our galaxy, and when we look toward the center, we see lots of, we're looking through all kinds of dust like this, okay? And so we cannot see what's over here on the other side. We can only surmise what's over there. There's stars over there we've never seen, ever, in the history of all mankind, humankind. We've never seen stars on the other side here. Okay? Not in any appreciable way. So it's like you're inside a forest forever and ever, and you can't see out of the forest. Michael Hedrick says, is there a probable limit to how big a planet life could live on? I mean, without being squished. Okay, well, let's think about that. Is there a probable limit to how deep in the ocean you can go before life is no longer viable? And the answer is, when you go into the deepest parts of the ocean, you'll see specialized creatures skittering along on the ocean floor in the bottom of the Challenger Deep, right? And that's extremely deep down there, right? We're talking about 37,000 feet down, and there's creatures down there. So if they evolve in that region, if they evolve there, well, then they're used to it. They don't know what pressure is, because that's what they are experiencing all the time, along with complete darkness. And once in a while, something comes along with a bright light on it, but you don't care, because you can't even detect light, you know, potentially. So, you know, creatures like that, they evolve in that place, and that in situ in those places, and so they're used to that kind of pressure, right? So if a planet is very large, a super Earth, for instance, say it's the size of I don't know, let's say Uranus, and it's an Earth-like planet, rocky, terrestrial, with an atmosphere. The creatures evolving there, and I think you get it, Michael, now, the creatures evolving there are going to evolve into that gravitational field. And so there might be a limitation on how far and what they can do in, say, a space program, should they ever become intelligent and get through the warrior phase and the nuclear era and so forth. But they may never get off the planet, because it might have too high a gravity for the inevitable chemical rockets they may invent. Now, they could also end up inventing rockets that have clusters of massive rockets to take them off the planet. And maybe they'll invent something clever to take them off the planet. That's very possible. So the bottom line is that there is really no limit that we know of. And I use the deep ocean as a model for that.
Took the words out of my mouth.
What?
Oceans.
Oh, yeah. Well, I had said that when
when
you went away. I said that, deep ocean creatures,
Yeah.
They don't know anything about pressure. They just know that this is their world. Okay, look at that. That's gorgeous, isn't it? Look at that detail, folks.
Yeah.
Clusters of young hot stars in there. Okay.
Several concentric dark bands you can see now.
I know. Now, when the moon's not out, we won't have this greenish haze. We won't have this reddish hue. This is all because of moonlight interfering with the sky and the color rendering of the camera. But I gotta say, I'm very, very happy with the way that the system is guiding. It's doing a phenomenal job.
Yep.
And everything we're looking for, we can find. The alignment of the telescope is really good. The guiding wouldn't be this good if it wasn't.
Still haven't dropped an image on this one.
I know. 45. 45 images right there. And 45 images. And boy, oh boy, that's pretty good. My mistake. I save exactly scene. Okay. Well, thank you, Mike. That's a very nice thing to say. Yeah, it's the universe live in real time. Go ahead, Daryl.
I don't mean to be a party pooper, but I'm turning into a pumpkin here.
Well, what kind of pumpkin?
An orange one, of course.
Well, I don't know if there's any other kind, but maybe there isn't.
Actually, there are.
Oh, orange pumpkin. That means you're a Trumpkin. Hey, that's pretty cool.
Okay.
I just made up a funny. Oh, see, Fantasy said, yeah, there are white pumpkins.
Yep.
Yeah, that's right. Rupert Rupkin. Hey, Ralph, how you doing? Ralph Wooden's with us. Ralph Wooden's a great astrophotographer, by the way, you guys. Look him up on Facebook. You know. That's okay, Ralph. You're late for the party, but we're about to end. With the moon out, I'm surprised it came in as good as it is. We're also shooting through high clouds. If you look at this is the other observatory 200 miles away, but the clouds are still the same. Look at the high altitude clouds. Look what we're shooting through. We're shooting through that, you know, and it's still rather impressive. And that's, like I said, what explains the reddening of our image. But that's okay. It'll be fine. Well, there we go. All right, I'm going to take this last image here, 50. We're going to save it here. There we go. All right, folks. Well, there you have it. We have done it again. We've opened both telescopes. It went beautiful this time. I think we've worked most of the bugs out, except for the bugs of the night sky having clouds. That's the only bug I don't like. But happy to have you with us. Thank you for coming along. Make sure you think about joining our Patreon, support us, or go to the Etsy store, buy some cool merchandise. Okay? I look forward to seeing you guys again, and I'm sure Daryl does too.
Sure.
Yeah. So you guys have a good night, and we will see you again. So good night, everybody.
Good night, all.
Oh, and don't forget, go to skytourlive.org and pick up these images we're shooting tonight. They're all free. Okay, so go down and find the appropriate link to go get cool pictures. All right, so good night, everybody. Have a good night.
Good night.
Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies. Universe in all its light. Sky tours bringing the views. light unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. SkyTour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. SkyTour is bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. SkyTour is bringing the views, every night feels brand